Hi, physics. Today we are going to be learning about projectiles launched at an angle. So here in the picture, you can see our projectile and that we are launching it at 30 degrees with 14 meters per second. And what we really want to find in today's problem is a horizontal range. This is our unknown that we want to solve for. So if you don't have the notes open, please open them up and you can follow along there. So the first thing that we should do is we should make our XY table. So we know the acceleration in the x always is 0 meters per second squared. And we know the acceleration of the y is always going to be negative 9.8 meters per second squared. But the velocity in the x direction is unknown. Obviously, we don't know the horizontal distance. We don't know the distance to the apex, that's unknown as well. And our velocity initial in the y direction is also unknown. So we have a lot of things that we're not aware of, but we can solve for them using first sine, cosine, and tangent, and then some kinematics. So the first thing that we need to do is we need to find the two different components of our vector triangle. So we have the hypotenuse. So I can do sine of 30 degrees is equal to the opposite side over the hypotenuse, right? This is the SO in SOHCAHTOA. So I know the hypotenuse to be 14. So then I can just solve for the velocity in the x direction. So it should be 14 because we're going to multiply both sides by 14. Sine of 30 degrees is equal to v sub x, and you should get 12.12 meters per second. If we want to find the velocity in the y, that's going to be using cosine. It's going to be the same sort of equation here. It's going to be 14 cosine of 30 degrees is equal to v sub y, and you should get 7 meters per second. Sweet. So now that we have these two components, we can put them back into the data table here, or our XY table actually. So this is 12.12 meters per second, and this is 7 meters per second. Alrighty. Now, since distance in the x direction is using a constant velocity, we're going to be using the physicist's first equation sheet, and you should find the equation velocity times time. Since we are only going to be using numbers in the horizontal direction, we want to specify that it is the horizontal velocity. Now, just a reminder, we split up that 14 meters per second because projectiles' velocities in the horizontal and vertical directions are independent of one another. That means they don't affect each other. So that 14 is going to be changing over time, but it's moving in both directions. So we need to split it up into the horizontal and vertical components so that we can deal with both of them. Because the horizontal velocity is going to stay constant, it's not going to change. But the velocity in the vertical direction is going to change. So it's not going to stay 7 meters per second the entire time. So when we look at this problem, we should first off notice that time is unknown. We don't have time, it's not given to us. So we're going to have to solve for it. Now remember that time sits outside of the xy table, or it exists on both sides because it is a scalar and not a vector. So if we look at our numbers though in the vertical direction, we only have two givens. We don't have anything else, but knowing some things about projectiles is going to help us. We know that the time up is the time down. Or another way to say it is that the time total, time sub t, is equal to twice the time up, or time to the apex. And we should know that the velocity at the apex in the vertical direction, so if I extend this out a little bit, velocity at the apex is equal to 0 meters per second. That 12.12 stays the same, but the velocity at the apex in the vertical direction is 0. So if I want to find the time to the apex, I can use an equation now, because now I know a final velocity. So I can use velocity final minus velocity initial over the acceleration. Or I can write this out as velocity at the apex minus velocity initial divided by the acceleration. Let's plug in our numbers because we have them all. We have 0 minus 7 divided by negative 9.8 meters per second squared. Cool. So our time to the apex is going to be equal to, if you plug in your numbers, right, 7 divided by essentially by 10, we're going to get 0.71 seconds. If we multiply that by 2, we are going to get 1.42 seconds. So that is our total time. That's the total time in the air. And since we now have this, we can then plug it back into our initial equation for distance in the x direction. So that's going to be 12.12 times 1.42. Take a moment to solve. And you should get a horizontal distance of 17.2 meters. So that last part went pretty quickly because we're just plugging in all our numbers. And notice that it takes several different steps to do so. So let's go over exactly what those were just one last time. So step number 1, we want to turn our 14 meters per second into its components, and we find those components here. Then we notice that this equation is what we want to use, but we don't know time. So we are going to notice that the total time, which is what we want to plug in here, is equal to 2 times the time to the apex, right? It's double that time. If time up is time down, right? Those two things are equal. So the total time is twice the time up. Then I can find my time to the apex by using this equation, and it's the velocity at the apex in the vertical direction. Remember, if I am using any vertical numbers, I'm going to stay on this side of the XY table. If I'm solving any numbers with horizontal numbers, I'm going to stay on this side of the XY table. It cannot cross. The only thing that can do that is time. Time can go on either side. So this is the velocity at the apex. We plug in our numbers and we get a time to the apex of 0.71. Then we can take that number, we can plug it back in here, and we find our total time in the air to be twice that, 1.42. We can now finally plug this back in and get our horizontal distance of 17.2 meters. So there are several different steps to solving projectiles launched at an angle, and this is the way that you can do it. There is a set of homework with the answers that I will post later on today. Make sure to take a look at that.